Hey guys, I hope that I'm live right now. If you guys are able to listen me properly, as well as there's no issues with the audio, please let me know. I know I'm not visible to you guys, that I am able to understand, but if you guys are able to listen to me properly, please let me know, guys. If there is any issues with the audio or the video, please let me know. The video, I know that I'm not visible, okay? But I hope so that the audio is clear to everybody, right, guys? No issues with the audio, right? Okay, great guys. Awesome, awesome. So guys, there are two ways of learning the machine learning algorithms itself. One is the correct way, one is the absolutely wrong way itself. So I want to make sure that you guys are able to learn in the correct way possible. The correct way, I think so, I've already told you guys to get an intuition behind the algorithm, to understand the mathematics behind the algorithm, to make sure that you guys are able to implement the algorithm possible as well. Okay, these are the three things that you guys need to do when you are learning machine learning. If you are missing out on either one of them, then you are not actually learning it properly. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. If you guys, सुसी बात में हाँ, अच्छा. If you guys are not doing this, guys, yes, the I think so the certifications for the previous bootcamp has been released. I'm able to see right over here for Python and artificial intelligence May 2024. People have started posting it up on LinkedIn as well. So yes, the certificates for the previous bootcamp has been released. Okay. Okay, so like I said, guys, that is what differentiates you from getting an internship or getting a job role and not getting a job role. These are the two things that differentiate a person who is able to get an internship and a person who is not able to get an internship. The reason for that is very clear because let me just put up your chat on my live screen, and I will also open up the screen share as well. Okay. So I don't have my tablet, so today I'm opening up the Google Meet and I'm sharing my screen on my iPad so that I'm able to like show you guys what I'm talking about. So like I said, guys, you need to understand something right over here that a particular person when he goes for an interview, right? There are going to be questions asked to him about his different kinds of projects that he has done. For example, if I'm going for an interview in machine learning or data science or artificial intelligence or data analytics, you guys are going to be asked questions related to that. So questions are going to be related to your, first of all, the first particular questions will be related to the intuition behind the algorithm. The second type of questions that are going to be asked are going to be related to the maths. Most of the people fail this type of questions, guys. Most of the people will fail the maths based questions because they never try to understand the mathematics behind it. And if you fail the maths question, you are definitely going to be failing the intuition questions as well because these are mostly interrelated in the interviews. This is where most of the people fuck up the entire interviews because the interviewer is able to see that you have created the project. Okay, so he's able to understand that okay, you already know the particular like okay, scikit-learn or something like that. He's not here to check that up. You have already coded it, you have already created the project. That means you know scikit-learn. What he will be checking is mostly intuition and mathematics. What he will be checking is your terminologies. Are you using the right terminologies or not? What he will be checking is your understanding of the algorithm itself. If you guys don't have these two, okay, if you guys don't have these two, then most likely you are going to butcher up your interviews, and that is not something that I want for you guys. The third one is implementation. The third one is implementation, but we are going to look at it at a later point of time. Okay, so in this particular boot camp I want to cover up all these three things for you guys so that you guys are able to understand how to learn a machine learning algorithm. Okay, How? Because see, we only have 7 days. There are 18 machine learning algorithms that are out there. So you have to learn all those 18 machine learning algorithms in the exact same manner. Now, after this bootcamp is over, you guys will have to learn the rest of the others on your own, or maybe through some resources or something like that. So I want to make sure that if you are continuing your journey further after this bootcamp, you're learning in the right way. So what I'm going to do for you guys is I'm going to take up one of the most easiest machine learning algorithms that are there, that is linear regression. Somebody said only 18 machine learning algorithms. So these are just pure machine learning algorithms that are 18. There are additional 6 deep learning algorithms. After these two, there goes a lot of different LLMs and your uh, big architectures itself. For example, the transformer architecture and everything. Each of those architectures will take you for like almost 15 to 20 days to learn one particular architecture itself. So, and all these 18 algorithms, to be able to learn the mathematics, to be able to learn the intuition, to be able to learn the implementation, will require you minimum of 1 week for every algorithm. So that is usually, so linear regression is a bit smaller algorithm in general, but it sets up a very good foundational knowledge for you guys that you can use to understand the rest of the algorithms as well. So that is my aim right over here. Okay, so linear regression algorithm is actually pretty simple, pretty straightforward. We are going to take up the example of house pricing. Okay, we are going to take up the example of house pricing to understand it, guys. Okay, so let's get started with it, shall we, guys? Let's get started with it, shall we? Let's start with the algorithm, guys. Shall we? Shall we not? What is the scenario, guys? Shall we start? Yes. Okay, great, guys. Awesome, awesome. Keep the enthusiasm a bit high, guys, right? Because I know maths is something that many of you guys will be like, "Arey, yaar, more theory. We are not here for that. Okay, we are here to learn the practicals itself." But we are here to actually learn for the interviews. We are not here to see what you guys want. We are here to make sure you guys are delivered what you need. Okay? Okay. So right over here, guys, the most basic supervised machine learning algorithm that exists throughout the entire world is called as linear regression algorithm. Now, there are multiple algorithms that are related to it. So, for example, polynomial regression algorithm itself, multivariate regression algorithms itself, normal regression algorithms itself, and so on and so forth. All these are related to linear regression. Linear regression is like everybody has seen Pokemon, right? Everybody has seen Pokemon. Please let me know. Everybody has seen Pokemon, guys. Please let me know. Yes. So think about linear regression algorithm as what was the name? What was the predecessor of Pikachu? Pichu, right? Pichu, Pichu. Yeah, Pichu. Okay. So basically, linear regression is like the Pichu inside of your simple regression algorithms. Pichu then basically evolves into your Pikachu, right? Pikachu. Okay, it evolves into Pikachu. Then Pikachu will evolve into Raichu. Pikachu then evolves into Raichu. Okay, so in the exact same manner, guys. For those who don't know Pokemon, I pity your childhood a lot. Okay, if even after not watching Pokemon, you are not in the top 3 colleges in India, then there's something very fucked up in your house. I will definitely suggest looking into it. Okay, so in the same way, linear regression is one of the most basic formats, and we want to make sure that you guys are able to understand this very well, guys. Okay, so let's go back. Let's try to understand linear regression. Okay, so we'll take up the example of predicting house prices. Okay, so we are having the size of a house, and we are having the like price of the house as well. Okay, so the size of the house, if let's keep the size in meters or in square feet or whatever you guys want to keep it in. So you are having the sizes as somethings. Okay, we'll just move it a little bit towards the right. Otherwise, that is not going to work for us. So we'll keep this as your serial number, then size, then you are having your price. Okay, so you are having right over here, guys. Okay, what we're going to do is the serial number one that denotes the first particular training example itself. The size of the house, let's say, is 100 square feet. Okay, is 100 square feet, guys. The price of the house is, let's say, let's keep it in dollars. Okay, $1,000 itself. So we can have the price of let's say for 10,000 rupees. Okay, $10,000 itself. $10,000 is the price. We can keep the price in $1,000. So instead of writing 10,000, we can just write 10. Okay, and we can place right over here that it is in thousands of dollars. Okay, thousands of dollars. In the exact same manner, we'll have the second serial number. We'll keep the price as 150. We'll keep size as 150 square feet. We'll keep the price as, let's say, 20. Okay, we'll keep the price as $20,000. In the exact same manner, we'll move further to the third particular serial number, wherein the size has now become 1,000 square feet. Okay, the size has now become 1,000 square feet, guys, and that would be somewhere around, let's say, 220, 200. Okay, so that is $2 lakh, guys. That is $2 lakh because we are pricing it in thousands of dollars. We're pricing it in thousands of dollars so that I don't have to write a lot of zeros right over there. Let's say, let's take up the fourth one. We'll have it 120, 1250, and we'll keep the price as $2,20,000. Okay, and so on and so forth up till the 47th number, up till the 47th row, 47th house pricing that we are having, in which we are going to keep the house pricing as, this is just random numbers that I'm keeping up, guys. Even I don't know what is the price. Okay, 2,750 square feet. Okay, and we are going to keep the price as, let's say, 300 or 325, that is $3,25,000. Okay, so these are all the data points that we are having. We call this as data points, guys. First of all, these are some terminologies that you guys need to understand. So that is the reason why I'm telling you guys about it. Okay, so that is called as our training data. First of all, this is our training data, guys. This is called as your training data right over here. Along with the training data, guys, you are having different items right over there, right? So your input, this is your input, right? This is what you will be giving to the model to predict the price, right? You will be giving the particular size to predict the price itself. Are you guys able to understand it? So you call the size as x. Okay, you call the size as x or input variable. Let me change the color. Maybe by changing the color, you guys will be able to understand it in a much more better manner. So we change the color to, let's say, white. Okay, so x is your input variable. Okay, it is the input variable, guys. Along with the input variable, you also call it as the feature. You also call it as the feature, guys. Now these are technical terms. Why is Shaurya Sinha called as Shaurya Sinha? Because the person who created Shaurya Sinha named him as such. Okay, in the exact same manner, these are technical terms. You don't call it as x, you call it as feature. Okay, that is the technical term that you need to use. Similar to that, price, what we want to predict is usually called as the output variable. represented by y. Okay, it is represented by y, guys. Okay, last line not visible. अबे मतलब गाली खाओगे, मतलब गंदी गंदी एकदम गाली खाओगे, हिंदी में दूंगा गाली। क्या करोगे लास्ट लाइन जान के? Is that of any relevance? That what was the last line? Is that of any relevance? No. The random numbers that I've used just to create a particular table. Focus upon what is x, what is y, what are the terminologies. That is what you need to focus upon. तुम लोग उल्टा डायरेक्शन में फोकस करते हो, अलग लेवल के लोग हो। ट्राई टू फोकस अपॉन व्हाट इज इंपॉर्टेंट, व्हाट इज नॉट इंपॉर्टेंट। भाई जूते के नीचे क्या ग्रूव बना हुआ है वो भी दिखा दो। How is that important? No. Okay. So in the exact same manner, it is also referred to as the target variable. It's also referred to as the target variable. So we call x as the features and y as the target, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Then you are having, so let's put it up right over here. So x is called as the feature, y is called as your particular target, then you are having a particular letter m. Okay, usually m is written, all these x, y and m are written in italics, but my handwriting is very shit, so I'm not writing it in italics itself. So m basically refers to the number of training examples, number of training examples in our current data set. How many training examples do we have in our current data set that we have created? This is our data set, right? The training data. How many training examples do we have, guys? Please let me know. How many training examples do we have right over here, guys? So the value of m will be equal to 47 in this case, right? The value of m will be equal to 47 in this case, guys. A single training example is usually represented by xi, comma yi. Okay. Now, usually this is written in two ways, either in this particular format or xi, comma yi. Okay. These are the two ways of writing it up. Everybody uses it differently. It depends upon who you are studying from. Both of them are correct. So I usually use this because it is much more easier to write down rather than the second version. But in most of the books that you will be using at a later point of time, if you are studying machine learning properly, you will see the notation to be of the second format. This is usually the notation that is used in books. But for writing purpose, for creating algorithms, for interview purpose, I use the first particular one itself. That is, for me, that is the better version to use. Okay. So for example, if I want to look at the first particular training data, right, the first particular training data, I'll be representing it as xi, x1. That is the first. I basically means which particular training example, which row are you talking about? So x1 comma y1, okay, would be equal to 100 comma 10. For example, if I'm talking about x4 comma y4, in that particular manner, I will be representing 1250 comma 220. That is how I will be referring to individual training examples, guys. A single training example or the ith training example itself. Are you guys able to get this? Please let me know. Are you guys able to get these? Please let me know, guys. Yes, everybody is able to get this. Nobody has any kind of problems in these terminologies, because now once we reach the mathematics portion, then don't tell me, sir, what does this mean? This is something new. I've not seen it up till this point of time. Don't be like that, guys. Okay. Now, if you look at what we are going to predict, right? We are going to predict that target, that is y, is your numbers. Now, these numbers can range from -33 to maybe 1,57,324. It can be anything, right? These numbers that we are predicting, right? These are numbers. They are not finite, they are infinite. Because for example, just between 1 and 2 there are infinite numbers. 1.1, 1.1.1, 1.1, okay, and so on and so forth. The infinite numbers itself. And hence these type of predictions in which we are predicting numbers right over there are usually called an infinite numbers, not finite numbers, not just like okay from 1 to 10, just these 1 2 3 4 5 6 7 8 9 10, these are the numbers that you have to predict. No, we are here predicting n number of numbers, infinite numbers. These type of models are called as regression models. Okay, these type of models are called as regression models, guys. Please do not forget about that. There are second type of supervised machine learning algorithms, okay, in which we call them as the classification model, okay, wherein the outputs, that is what we are going to predict, are going to be categories. For example, is this picture of a dog or a cat? Are there infinite like animals right over there? No, we are just predicting for cat and dog. It's finite. These are called as classification models, right? Is this particular picture of which number, right? From 0 to 9. Which number is it of this particular picture? This is also a classification model. Um, taking in your particular blood report and predicting which particular like health problems you are having or which particular disease you are having, right? This is also finite number of diseases that are there. So again, this is also a particular classification model. Are you guys able to understand the difference between regression and classification models, guys? Please let me know. Are you guys able to understand the difference between regression and classification models, guys? Please let me know. You guys have any questions? Please let me know. Until here, are you guys able to understand this, guys? Please let me know. Great, guys. Awesome. So the next thing that we are going to work on right now is that we are going to try to learn. Again, we are going to try to understand how does an algorithm actually learn. Okay, how does an algorithm actually learn, guys? Okay, we will build an algorithm, we'll do all kinds of crap, but how does it learn right over there? So let's think about it in such a way. You are having your training set, right? What is that? Train training set. Okay, this training set is comprised of your features, that is x, and your targets, that is y, right? This type of training sets basically consists of your features x and your targets y. Now, the algorithm at the end of the day, the machine learning algorithm is nothing else but a learning algorithm, a mathematical equation itself. Okay, we call it as a learning algorithm. Now, this learning algorithm can be anything. Okay, for our purpose, is it a linear regression algorithm itself? Okay, so any mathematical function can be represented by the letter f, right? Any function in mathematics usually gets represented by the letter f. If you guys have not forgotten about your maths classes, wherein the inputs that are coming into f is x, and the output that you're getting from this f is your y hat. What is the difference between y and what is the difference between y hat, guys? Let's try to understand this, guys. What is the difference between y and what is the difference between y hat? Okay, so your f function is your learning algorithm, the machine learning algorithm that you guys have created, also referred to as a model. Okay, not the model that walks on the ramp, right? Or not the model that you guys make of action figures. This is basically called as the model itself, the learning function, right? The f, that is the algorithm, is called as the model. Now this algorithm, when you feed in the x, it will generate an output for you. This is not the output from your training set, guys. This is not the output from your training set. Your particular model, when you feed in the X to it, it will generate an output for you, right? This generated output is a new output that you have received, and that is called as Y hat, the output that the model has given you. the desired output that was there, the output that we actually wanted for the value of x was your target, that is y. The actual output that you guys wanted was your y, guys. That was in the original training set. Your y hat can be equal to y, but it is not compulsory. Y hat is the prediction. Y is was the desired output, the actual output that we wanted. Are you guys able to understand the difference between the target and the prediction? Are you guys able to understand the difference between the target and the prediction, guys? Please let me know. Yes, everybody is able to understand it. It's simple, guys. If you were paying attention from the starting of the class, you will be able to understand it. If you were even absent for a single minute, you will not be able to understand it. It's as simple as that. Okay. Now, how do we represent this f, our model? Okay, what is this f right over there? For our purpose, f is a linear algorithm, a linear function, because we are learning about linear regression, guys. So f is a linear function, a linear function of x. Okay, that is f of x. What happened? F of x is equals to y hat. This is what your f is. Now, how do you represent in mathematics? This is something that I think so we have learned in the sixth standard itself. This is not new. How do you represent a function of x that is a linear function, guys? How do you represent that? How do you represent a linear function, guys? We have learned this in standard 6. This is not new. This is not even related to machine learning. We're talking about 6 standard stuff. How do you represent a function of x that is a linear function, guys? A of x plus c is equals to y. Very good. A of x plus c is equals to y. Where a or a plus b is equals to y, whatever you guys want to say, or y is equals to mx plus c. That is also the right way of putting it up. Right? All these are right. Where a and c or m and c are all constants. Where x and y are your variables. In the exact same manner, here as well, we represent f as a function of x by writing f of w comma b, which can also be written as f of x is equals to wx plus b, which is equals to your y hat. F of w, all these are the exact same thing, guys. It can be written as f, that is a function of wb of x, is equals to f of x, that can be simplified in that kind of manner, is equals to wx plus b, which is equals to your y hat, guys. That is your prediction that you guys are having. That is your prediction that you are having, guys. Okay. Now, these are predicted values. Please try to understand this. These are predicted values. This function is your prediction itself. For example, if I plot the entire thing down, right? So let's assume this is my plot. These are all your x's. These are the, let's not write x, let's write your size. This is your price, and we'll use certain color to note down your particular values. So right now I'm plotting the table, the particular data points that we are having. Okay, we are plotting the data points that we are having, guys. So let's say these are the different data points for x and y values. These are all the different data points that exist for x and y values, guys. Okay, these are all the data points that exist for x and y values. Okay, are you guys able to understand this? This is your x comma y, xi comma yi. Wherein, for example, this is your x1 comma y1, this is your x2 comma y2, and so on and so forth. Okay, so these are all your x comma y values right over here. Now your prediction that you have created, guys. Now your f of x that is there would be a straight line because this is wx plus b, right? This is wx plus b, guys. So that is a straight line right over there. So it looks something like this, right? A good straight line will look something like this right over here. This will be your wx plus b. Okay, this will be your wx plus b. This is what your f of x actually represents. The regression line, as rightly said by many. This is what your regression line will be represented by. Now, if we take up a particular value, for example, we take up this particular value of x, okay, this is x1, guys, this is x1. So for that value of x1, we are able to see that the y1 is basically somewhere here. This is your y1, guys. Whereas for the same value, if you try to find your particular y hat, okay, this is the value that corresponds to the y hat 1. That is the predicted value for the first particular data point. Are you able to see there is a difference between the prediction and the actual value? There's a difference between the prediction and the actual value, guys. Are you guys able to see this? Please let me know. Are you guys able to see this difference that is there between the predicted and the actual value that is there? Are you guys able to see that? Please let me know. Yes, this difference needs to be as small as possible to find the right f of x. Okay, to find the right f of x, guys, this can be like, I can put up a line like this as well. This is a new line that I'm putting up in green color, right? But as you're able to see, this does not appear to be the right line. This does not appear to be the right prediction line itself, guys. It gives us a wrong particular values for most of the numbers. It does not feel right, right? So in the exact same manner, guys, we need to find a way to figure out what will be the values of w and b. By changing the values of w and b, we get multiple lines, right? So what will be the correct value of w and b so as to get the line which reduces our error, guys. For this particular purpose, the humans created a new particular function called as the cost function. They call it as the cost function. This cost function is what helps us to figure out the right values of w and b to find the most fitted line, guys. To find the most fitted line, a good fit line, guys. Okay, that is what the cost function actually does. Let's try to identify how to get these cost functions. First of all, one more thing, guys, this w and b are also referred to as parameters. I think I went a little bit upstairs. Parameters or coefficients, or you can also refer to it as weights. Okay, this w and b, again, guys, this w and b, you can refer it to as parameters, coefficients, or weights, guys. Okay, very good, Mr. Singh. But right now, please focus upon the class. Right now, we are talking about the mathematics. We are not writing the Python program right now. We're talking about the understanding of the algorithm, the maths behind the algorithm. Once we do that, then we'll go towards the coding of the algorithm. That is the right way of studying. If you directly jump to writing code, then you're not actually learning the algorithms properly for getting a placement. Okay, so again, guys, I can also just be like, okay, these are the this is the project, let's code it completely and I will be done with that. Why do I need to teach you guys all this mathematics and everything? The reason for that is because it's important. Because I am an interviewer myself. I've taken up almost 300, 400 interviews in the past 3 years. I've taken up interviews for Microsoft. I've taken up interviews for Walmart, Wells Fargo, Goldman Sachs, JP Morgan. So I'm one of the interviewer that is there. So maybe in some day you will be seeing me on the other side of the bench as well. So I'm talking to you guys from the perspective of what we as interviewers ask in the particular interviews. We don't see a project and be like, oh, very good, wow, let's move on, right? You are selected. We ask you these type of questions. Okay, so you have to make sure that you guys are able to understand these concepts and you guys are able to answer these concepts in the interviews as well. That is the main point right over here. Okay, so the cost function, right? How do we understand what is the cost function right over there? So let's try to understand it in such a way. Cost function is basically the error that is there in your code. Right now, if you look at this particular graph, guys, right now, if you look at this particular graph, how would you calculate the error? The error is basically the difference between the predicted value and the value that you actually wanted, right? That will be your particular error that you're getting in your prediction. Whatever value that you predicted, right, by hat, and whatever value that you wanted from the algorithm, that is y, right over there, right? No, interviews don't focus upon college tax. Okay, no interview does that. College tax is important in some other manner, not in interviews. Colleges, if you are in a good college, companies will be coming to your college to take up interviews. That is why getting into a good college is important. Outside the college, if you're going for interviews, that is not important. Which college are you from? Nobody cares about it, except in the cases of you getting into MBA. Okay, in MBA, companies care from which particular college have you actually studied from. So that is a separate thing. But for people who are applying to get into tech, companies don't give a shit about it. Okay, so that is what we want to do. To calculate the error, we want to calculate all the different errors that are possible, guys. So to do that, we will be having y hat minus y. Okay, y hat minus y. For each of the data points, for each of the data points, guys, that is from y1 to ym. Okay, for each of the data points, that means we will be adding from I is equals to 1 to I is equals to m, all the values, all the differences from y hat I, that is from the first particular prediction with the last to the last particular prediction itself. That is what we will be doing right over here. But there is a big problem. Basically, what I'm saying is all these differences, right? All these differences that you are able to see, we're going to add all these differences up to get our final error, guys. To get our final error. Okay, are you guys able to understand all these lines that I've drawn right over here? That is basically y hat minus y. Okay, for each of the data points, we're going to add all these green lines up together to give us our cost, to give us our net error, guys. But look at this. What we are doing right over here is y hat I minus yi, right? So for these cases, it is going to be negative. This will all the particular lines that are above our blue line, right? All that will be negative right over there. This will also be negative. This will also be negative. All the ones that are below the blue line, that is going to be positive, right, guys? All the lines, green lines that are below the blue line, that is going to be positive right over there. This is also going to be positive. This is also going to be positive. This is also going to be positive, right? If you are not able to understand why they are going to be negative and why this is going to be positive, then I think so you need to go back into the second standard once again and start learning mathematics again, guys. Okay, that will be my suggestion for you guys. Are you guys able to understand this or not? Please let me know that why the green lines that are above the blue line are going to be negative and why the green lines that are below the blue line are going to be positive in nature, because we are doing y hat I minus y I. Doing y hat I minus y I. Y hat I is in cases which are smaller will give us negative values, which are bigger will give us positive values. Nikita, I think so. You need to go back into the second standard and understand what is mathematics once again. That if you say, like negate a bigger number from a smaller number, then you get a negative value. So that is something like if you're having one cookie and I take away two cookies from you, you get negative one cookie right over there. Okay, you still owe me a cookie. Okay, so that if that is how you want to learn, I cannot teach in that manner. I I expect students coming to this boot camp to actually know basic mathematics of like subtraction and what is graphs and what is a function itself. That is like 10 standard, 6 standard stuff. I'm not here to explain that. I can only explain whatever concepts that is there in colleges or whatever concepts are not taught in schools itself. I can only do that. Okay. Uh, okay. So right over here, guys, there's a big problem. So if I am adding all these differences up, that is y1, y1, my y hat 1 minus y1, okay, plus y hat 2 minus y2 plus y hat 3 minus y3 plus dot y47 hat minus y47. If I add all these number up, some of them are going to be positive, some of going them are going to be negative itself, right, guys? Some of these particular subtractions are going to be positive. Some of these particular subtractions are going to be negative, right? Are you guys able to understand this? So adding all these positive and negative numbers together itself, right? Um, there might be a case in which all these numbers when added up might be equal to zero. There might be a case in which all these number up when added together might be zero. Right, guys? 47, because in our original training data we had taken 47 rows. That is the reason why I have written 47 right over there. Okay, it might be equal to zero, but from the graph, as you're able to see, there is error. It is not equal to zero, guys. There is error. It is not equal to zero. Are you guys able to understand it? If we add this up together, we are getting a zero right over there. But if we look at our graph, we are immediately able to see that that is not the case. There are errors in our particular prediction itself, right? There are errors in our prediction itself, guys. Now, how do we solve it? We have to make sure that whenever we are subtracting our predicted value and our target value, we have to make sure that they are always positive. How can we make sure that any number is always positive, guys? Please let me know. Again, this is something that you guys have learned in 8th or 9th standard itself. This is not something that is new. How to make sure that a number is always positive, guys? Please let me know. One of the answers that Kavish has given very correctly is taking modulus, is taking a mod right over there. What about the next stuff, guys? What about the second particular option right over there? Modulus, taking modulus is absolutely good, but what about the another method, guys? What is the another method to make any number always positive? Mod is always good, guys. Mod is always good. What about another method? Square. Very good. Very good. Squaring is the next particular option, right? So what we can do is we can represent this cost function as summation from I is equals to 1 to m, where m is 47 or whatever you guys want to take it up. Either we can do mod of yi hat minus yi ka summation, or we can do summation of I is equals to 1 to m square of y hat I minus yi square. There are two ways in which we can make sure that our error is always positive. Now, here we are only having 47 data points, right? Here we are only having 47 data points. In an actual data set, there can be millions of data points as well. There can be hundreds of millions of data points as well. Now, in that particular case, if all these numbers are always positive, if all these errors, this errors that we are subtracting, right, is always positive, then by adding all the million errors, this error will get very big, right, guys? By adding all these million errors, this error will become very big right over there. We don't want that to happen, right, guys? We don't want that to happen. So what we do is we calculate the average of these errors. We try to calculate the average of all these errors, guys. So we'll divide this by m. We'll divide both of them by m, where m is the number of training data that is there, to make sure that our particular value that we are getting, that is the error cost function that we are calculating, does not get bigger and bigger with more and more data, guys. Positive क्यों करना है? SS creations, I will suggest you scroll back the video a little bit back and listen to me once again when I was explaining this particular part. When you add positive and negative numbers, the cost becomes zero, the error becomes zero. But by looking at the graph, the error is not zero. I'll suggest reverse back the video a little bit and listen to me once again because I've already explained it. Okay. Similar to that, guys, one more thing that is there inside of the cost functions that we use is that we also divide it by 2. Okay, so why do we do it? Because later on in the found out by like the people, not we, the researchers who actually created the cost function, found out by that dividing it by 2 actually gave a good answer, a better error function when compared to just by dividing by m. Again, that does not mean like you can do anything, but this is usually the right way of representing the cost function, guys. Now these cost functions have a name associated to it as well. This is called as the squared cost error cost function, guys. Squared error cost function, and similar to that, this is called as mean error cost function. These are the name of these two cost functions, guys. And cost functions is usually represented by j of w comma b is equals to 1 by 2m summation of I is equals to 1 to m y hat I minus yi d square. This is how you write a particular cost function. It is represented by j of wb, guys. This is represented by j of wb, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. You can also represent your yi hat by your f of w comma b x of I. You can also represent it as this because that is what your y hat actually means. If you guys remember it from right over here, this is the function that I'm referring to. Okay, this is the function that I'm referring to, guys. So you can represent your y hat I as a function of x as well, as I've done right over here. Now, what is the aim? Okay, what is the aim, guys? We need to find such values of w and b. We need to find such values of w and b so that our cost of the entire function reduces, right? We need to find such values of w and b so that the cost is the least, our cost function actually is the least itself. That is the aim. We need to find the right value of w and b so that we are able to plot the linear regression, right? We need to find the line. The line is represented by this w and b. So we need to minimize this cost function with respect to w and b so that we are able to find the cost, to find the right line itself, to find the right line. Now this is where concepts of gradient descent and everything else comes into picture. That is what we are going to learn in our tomorrow's class. I don't want to overburden you in the first session itself of mathematics. Okay, so you can write it out as minimize with respect to w comma b j of w comma b, which is equals to 1 by 2m summation of I is equals to 1 to m of f of w comma b xi minus yi the whole ka square. This is how you guys can refer. If you are able to minimize this particular function with respect to w and b, you will get the value of w and b, guys, and that is how you get your final particular linear regression line. Okay, and the same thing gets propagated further. So to do this minimization itself, what you guys might have learned in mathematics is your differentiation, right? If you guys remember it, okay, to find the minima and maxima of any of a function itself, because remember that to find the minima and maxima, I think so this was in 11th or 12th standard. To find the minima or maxima of a particular equation, you used to differentiate it by that particular like variable, and then you used to equate it by 0 to find the minima and maxima, and then you used to replace it within the function to get those values itself, right? So that is mathematically how you do it, but for a computer to do that, it's pretty difficult. So we will understand how does a computer finds the minima, and the name of that particular algorithm is gradient descent. Yeah, I've just my G has become C and R. Okay, my handwriting is not very good. Gradient descent. That is what we are going to learn in our tomorrow's class, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Yes. Tomorrow we will be finishing up with our mathematics, guys. And then day after tomorrow, we are going to start with the practical implementation of linear regression using Python. So that is my current aim, to make sure that you guys are able to learn it in the best way possible. Mean cost function is better than squared function cause less error is lesser, right? Not at all. Actually, the much more used cost function is the squared cost function itself. The reason for that is even smaller errors get like smaller errors when you square them, it is basically not making a lot of difference. Whereas when you have big errors, when you square it, it becomes a very big error itself. So that makes a lot of difference in the gradient descent algorithm. So in supervised machine learning algorithms, in almost every single place you will find people using squared errors cost function everywhere, instead of using the your absolute cost function. That is what I've usually seen. Even I use that mostly itself. Okay, so right now let me give you guys the attendance link for today's class. Whom Shia, they will be contacting you very soon. It takes us time. Like I've already told you, 1,000 people apply for the internship every week. We have only 2 people who reach out to them, so it is going to take us a bit time to reach out to every single one of you guys, right? Okay. When we square, we get positive, but the error value also gets squared. That is the point. So there might be smaller errors, right? Let me explain that to you guys after sharing the attendance. Let me share the attendance and then explain it to you guys. I'm not like professor. I'm not going to tell you that, oh, good question. I'll come in tomorrow's class and explain it to you guys, right? That is the difference between learning it from professors and learning it from people like us. We do this on a daily basis. So we are able to understand it much more easily when compared to professors. Okay, that your question is very genuine and very good as well, actually. I didn't expect such a question from you guys. But nevertheless, let's talk about it after sharing the attendance. हाँ सभ्यता अग्रवाल, तुम्हारा 2 नंबर्स को नेगेटिव करने में आयोटा कहाँ से आ जाएगा, जरा बताना तो जरा। मतलब बकचोदी करना है तो कर लो, बट ऐसा मत करो कि खुद ही चूतिया लगो। ठीक है? So right over here, guys, I have provided guys the attendance link as well. The attendance link will be closed exactly at 9:17. So start filling up the attendance. Okay. The person who was asking me the question related to that, once you're there in the class, please let me know. James M. Once you fill up the attendance and you enter into the class, let me know. I'll explain you about like the question that you were asking. Okay. Like I said, guys, James M, your question was very good. Once I filled up the attendance, let me know in the live chat. I'll explain you like what you were not able to understand. Okay, James M, once you are back in the class, do let me know. James M, once you are back in the class, please let me know. Okay. Yeah, James, let me explain it to you. So let's look at this particular example, right? Let's look at this particular example right over here. Tell me something. If I am, is this particular error, this is a very small error right over here, right? This is a very small error right over here. This is also a very small error right over here. This is a large error. This is a very large error right over here itself. Which error makes you shift your particular line in the right direction? Is shifting according to the smaller errors important or shifting according to this larger error important? Please let me know. Okay, I have not shared the screen. Right. There are three errors right over here, right? These are both small errors right over here, and this is the large error. Which particular error makes you shift your line? Like, what is the aim of the cost function? To change the particular values of W and B to reduce the cost. That means change the direction of the line itself, right? Change the direction of the line itself. So, which particular error would make you shift the line much more? Will you shift the line according to the smaller errors, or will you like to shift the line more according to the larger error, guys? Larger one, right? So when you are having square, okay, when you are having square of the errors, square of a small number is actually very small. Square of even a smaller number is actually very small. Square of a large number is larger. That means it is making more weight to change the particular like line itself, change the direction of the line itself. That is the reason why we prefer square errors, because square errors having a larger error exaggerate the errors itself, exaggerate the larger error, makes the larger error even more larger to make sure that your line is changing accordingly. Large errors have much more weightage than the smaller errors to change the direction of the line. Are you able to understand this, James M? Are you able to understand this, James M? Please let me know. Able to understand this, James M, guys? Please let me know. Yes? Okay, good. I've missed 2 days attendance. What can I do now? See, if you're missing 1 or 2 days of attendance, we still give you guys the certificates. Okay. 2 days of attendance, it depends upon my mood on the last day. If my mood is good, I give you the certificates. If my mood is bad, I don't give you the certificates. But for 1 day of attendance, everybody gets the certificates. We are able to understand that. Okay, so you don't have to worry about it. Okay, so the attendance is closed right now. We'll meet in our tomorrow's class and we'll continue from right over there. Thank you so much, guys. Bye bye. Bye bye. Bye bye, guys. Bye bye.